Hello Tanga, welcome to Gully Classroom. This is the 6th lecture in the chapter Acids, Bases and Salts in CBSE 10th Standard Chemistry Science Book Chapter 2 Acids, Bases and Salts. This is the 6th lecture taken in English. This is the 6th lecture taken in English. Okay sir, what are we going to see in this particular lecture? In this lecture, we will learn about amphoteric oxides, then we will learn about the different types of salts. We will learn about neutral salt, we will look at a couple of examples. We will learn about acidic salt with a couple of examples and also basic salts with a couple of examples. Okay sir, what next? We will learn about Chlor Alkali process and the applications of products of Chlor Alkali process. We will also learn why this process is called as Chlor Alkali process. Finally, in this particular lecture, we will learn about how bleaching powder is manufactured and what are the applications of bleaching powder. Yeah, can we start the lecture? Come on guys. What are amphoteric oxides? Amphoteric oxides are metallic oxides. So metal and oxygen combine to form metallic oxides, and these metallic oxides have both acidic and basic properties. Metallic oxides, some very specific metallic oxides have both acidic and basic properties. These are called as amphoteric oxides. Sir, I am able to understand the definition that metallic oxides which have both the characteristics of acidic and basic will behave as amphoteric oxides. But give an example. Help me to understand with an example. For amphoteric oxides, the standard example is aluminium oxide and zinc oxide. Let us take aluminium oxide, Al2O3. I am going to put aluminium oxide with hydrochloric acid. Here aluminium is more reactive than hydrogen. Aluminium will replace hydrogen from this particular compound. So you will get AlCl3. AlCl3 plus what else will you get sir? You will get H2O. Okay, let me balance this particular equation. Here I have 2 aluminium. So I am going to put a 2 here. So I have 6 chlorine. I am going to put a 6 here. Yeah, I have 6 hydrogen. So I am going to put a 3 here. 3 into 2 is 6 hydrogen. Oxygen is 3 on both sides. This equation is balanced. What is happening here? Here an acid is combining with aluminium oxide which is behaving as a base. Here hydrochloric acid is combining with aluminium oxide which is behaving as a base, and it is giving me salt plus water. Sir, this is just like a neutralization reaction. Okay sir, now continue further. What will happen if aluminium oxide is going to react with a base? Let us take our standard base, caustic soda or sodium hydroxide. Here we will get Na2Al2O4 plus H2O. Sir, what is Na2Al2O4? Na2Al2O4 is called as sodium aluminate. It is called as sodium aluminate. Okay, if you notice here, we have taken a base. Caustic soda or sodium hydroxide is a base. Aluminium oxide is behaving here as an acid. Here it is forming salt plus water. So what is the beauty of aluminium oxide? Well, aluminium oxide is reacting with an acid. It is behaving like a base. When aluminium oxide is reacting with a base, it is behaving as an acid. Let me repeat myself. Look at the beauty of this. Aluminium oxide, when it reacts with an acid, it behaves as a base. Aluminium oxide, when it reacts with the base, it behaves as an acid. So, aluminium oxide has the properties of both acidic and basic. Such oxides are called as amphoteric oxides. Are you able to understand this particular idea? Can we look at another example? What is the other example? Zinc oxide. Let us take zinc oxide. You are going to put zinc oxide with H2SO4 sulfuric acid. Okay sir, what is happening? Here zinc is more reactive than hydrogen. So zinc will displace hydrogen here. If zinc is displacing hydrogen, I will get ZnSO4 plus H2O. Okay sir, this equation is automatically balanced. This equation is automatically balanced, so it is not an issue. Okay, with this particular equation, I forgot to balance this equation. I think I need to put a 2 over here. Yes, that particular equation is balanced. Let me continue here. Here zinc is behaving as a base. Zinc oxide is behaving as a base. It is combining with the acid and it is producing salt and water. Okay sir, what does zinc oxide, how does zinc oxide react with our standard base, which is NaOH caustic soda, In this particular reaction, I will have an extra water molecule. In this particular reaction, I will have an extra water molecule. So with this particular reaction, what will I get? I will get a coordinate compound Na2ZnOH, Na2ZnOH4. So this is called as a coordinate compound. We will study more about coordinate compound in our higher secondary inorganic chemistry. This is called as a coordinate compound. We will study more about coordinate compound in inorganic chemistry in higher secondary classes. So let us not worry about it, but look at the beauty of this. Here when zinc oxide is combining with the base, zinc oxide is behaving as an acid and it is producing a salt, So zinc oxide, when it reacts with an acid, it behaves as a base. When it reacts with the base, it behaves as an acid. Zinc oxide is also a good example of amphoteric oxides. So amphoteric oxides can react and dissolve in both acids and bases. Amphoteric oxides can react and dissolve in both acids and bases, but amphoteric oxides are not soluble in water. Amphoteric oxides are insoluble in water. Are you comfortable with what are amphoteric oxides? Are you comfortable with my examples? Can I rub this off? Yeah, cheers. Now let us look at salts. Sir, what are the different possible types of salts available? The different types of salts that are available are neutral salt, acidic salt and basic salt. Neutral salt, acidic salt and basic salts. Sir, how are you going to classify which is a neutral salt? How are you going to classify which is a acidic salt? How are you going to classify which is a basic salt? What is the idea behind neutral, acidic and basic salt? It is very simple. When a strong acid is combining with a strong base, in order to learn what is strong acid and strong base, type strong acid and strong base Gully Classroom, go to that particular lecture, learn the concept completely, then come back to this particular lecture. Yeah, let us continue. When a strong acid reacts with a strong base, what is happening? You are getting a neutral salt, which means the pH of the salt will be equal to 7. Sir, give us a couple of examples of neutral salts. Okay, let me give you a couple of examples of neutral salt. The common salt that we eat every day, NaCl, is a good example for neutral salt. Where do we get this Na from? We get this Na from NaOH. Okay, where do we get this Cl from? We get this Cl from hydrochloric acid. Let us try this particular idea in reverse. Sodium hydroxide and hydrochloric acid combine with one another to form water, H2O, and what is left? NaCl. So NaCl or sodium chloride is a good example for a neutral salt whose pH will be 7. When I look at this NaCl, I can detect the acid and the base that were used to form this particular salt. How, sir? First there will be your metal. From the metal, add OH to the metal. Add OH to the metal or add OH to the positive ion. Let me repeat. Add OH to the positive ion. Add H plus to the negative ion. If you add OH to the positive ion, you will get the base. If you add H plus to the negative ion, you will get your acid. Yeah, are you comfortable with this particular idea? Can I give you another example for this? Yes, sir. Okay, let us go for K2SO4. With respect to K2SO4, K2, which is the positive ion, I will get K2 from potassium hydroxide, KOH. What about SO4, sir? I will get it from sulfuric acid. You need to add the negative ion. SO4 is 2 minus. You need to add the negative ion to hydrogen. So I have sulfuric acid. Here both of them, potassium hydroxide and sulfuric acid are. This is a strong base. This is a strong acid. When strong base combines with a strong acid, we get a neutral salt K2SO4. Similarly, here also NaOH is a strong base. This is a strong acid. So they combine to form a neutral salt. Sir, give us another simple example. Na2SO4, sodium sulfate. Na2SO4. Sir, how are you going to analyze this? Okay, let me break this. Metal or positive ion, you need to combine with OH. So NaOH or sodium hydroxide, SO4 2 minus. SO4 2 minus is the negative ion. You need to combine it with hydrogen. So you get it from H2SO4. NaOH is a strong base. H2SO4 is a strong acid. So the salt to form is obviously a neutral salt. Are you able to understand how we are analyzing the neutral salt? Okay, sir, I am comfortable. Now let us look at a couple of acidic salts. We will go for acidic salts. How are acidic salts formed? Let me repeat. How are acidic salts formed? Acidic salts are formed when we have a strong acid but a weak base. Similarly, basic salts are formed when we have a strong base but a weak acid. The idea is whichever is strong is repeated here. If we have a strong acid and a weak base, it is an acidic salt. If we have a strong base and a weak acid, it is a basic salt. Yeah, can we look at a couple of examples of acidic salts? Okay, a very famous example of acidic salt is NH4NO3. What is this called as? This is called as ammonium nitrate. This is called as ammonium nitrate. Okay, let us break it into its constituent ions. Ammonium is the positive ion, nitrate is the negative ion. For the positive ion, you are going to add OH. So you will get NH4OH, which is ammonium hydroxide. This is nothing but ammonium hydroxide. Okay, sir. What about NO3? You will get NO3 from nitric acid. Okay, here nitric acid is a strong acid, but ammonium hydroxide is a weak base. Ammonium hydroxide is a weak base. When a weak base combines with a strong acid, you are getting an acidic salt. So ammonium nitrate is an acidic salt. Okay, sir, give us another example. Let us go for NH4Cl. What is NH4Cl? Ammonium chloride. Let us break it into two. Here NH4. NH4 plus Cl minus. NH4 is the positive ion. So you are going to put it with OH. NH4OH is once more ammonium hydroxide. Ammonium hydroxide is a weak base. What about HCl? You will get HCl from hydrochloric acid, which is a strong acid. Once more, a strong acid is combining with a weak base. You are getting an acidic salt. Both ammonium nitrate and ammonium chloride are good examples for acidic salts. For acidic salts, the pH will be lesser than 7. For acidic salts, the pH will be lesser than 7. Yeah, just like acids. Just like acids. Okay, let me rub this off. Next, for the last one, we are going to study about basic salts. So obviously you are going to have a strong base and a weak acid. Okay, sir. How many examples are we going to see? Let us close this with just one example. What is our example? Let us say Na2CO3, sodium carbonate. What is the common name for sodium carbonate? The common name for sodium carbonate is called as washing soda. Okay, what is this made up of? Break it into the ions. Here, Na is from NaOH. NaOH is a strong base. NaOH is a strong base. What about CO3 2 minus, sir? CO3 2 minus is from H2CO3. What is H2CO3? H2CO3 is nothing but it can be simply called as carbonic acid. H2CO3 can be called as carbonic acid. What is in fact carbonic acid? Carbonic acid is nothing but the soda that we drink. Carbonic acid is nothing but the soda that we drink. So carbonic acid is nothing but a combination of water and carbon dioxide. What is soda? Soda is a combination of water and carbon dioxide. Okay, let us count the total number of atoms here. Here 2 hydrogen, H2, 1 carbon, O, 3 oxygen, O3. So H2CO3 is nothing but a literal combination of water and carbon dioxide. This can be simply called as a weak acid. So when a strong base combines with a weak acid, we get basic salt. So washing soda is a good example for basic salt. Sir, can we have another example? But I told you I am going to look at only one example. Come on, sir. I will give you 15 seconds. Give us another example. Okay, let us go for NaHCO3. What is NaHCO3? NaHCO3 is sodium bicarbonate, or it can also be called as sodium hydrogen carbonate. Let me break this into its ions. Na plus. Okay, from where will you get Na plus? You will get Na plus from NaOH, which is in fact a strong base. From where are you going to get HCO3? You are going to get HCO3 from weak acid, which is carbonic acid. So basically both the salts, what salts? Sodium carbonate and sodium bicarbonate. Sodium carbonate and sodium bicarbonate are made up of the same acid and a base. They are made up of a weak acid, carbonic acid, and a strong base, sodium hydroxide. Sir, what is the common name of sodium bicarbonate or sodium hydrogen carbonate? It is called as baking soda. It is called as baking soda. We will learn about washing soda and basic. We will learn about washing soda and baking soda in the next lecture. That is basically the end of what? That is basically the end of basic salts. What are these salts? These are called as BASIC. Basic salts. Comfortable with this? Okay, sir. Sir, what is the next thing that you are going to teach? I am going to teach about the Chlor Alkali process. What is Chlor Alkali process? Chlor Alkali process is simply a method of manufacturing sodium hydroxide or caustic soda. Chlor Alkali process. Chlor Alkali process is simply a way of manufacturing. What are you going to manufacture? Sodium hydroxide or caustic soda. In fact, the process is called as Chlor Alkali process because we are getting also chlorine as a product. Because of this process, you are also getting chlorine as a product. So it is called as chlor. You are getting sodium hydroxide as a product, and sodium hydroxide is an alkali. So the entire process is called as Chlor Alkali process because you are getting Chlorine and the alkali has the output. You are getting chlorine and alkali has the output. Are you comfortable? Why this particular process is called as Chlor Alkali process? Okay, sir. What next? How are you going to do this particular process? You are going to have a structure like this. You are going to do an electrolytic reaction. What is electrolytic reaction? Electrolytic reaction. Let us divide this word into two. Electro means using electricity. Lighting means breaking. So what are you going to do? You are going to break this particular electrolyte. You are going to break this particular electrolyte using electric current. Okay, sir. I am getting an idea of what is happening, but still illustrate this better. Let me put two electrodes here. These are called as electrodes. Okay, once I have put the electrodes, I am going to connect them to a cell. I am going to connect them to a cell or power supply. Okay, now what is happening? Here I am taking brine. What am I taking? Brine. What is brine? Brine is a very thick solution of salt. I am repeating myself. Brine is nothing but a very thick solution of water and salt. The brine will be more or less like paste. There will be so much salt in water that it will become a paste. That is called as brine. You are taking brine in a vessel, dipping two rods and connecting it to a cell. Now what will happen, sir? Brine is nothing but salt. So let me write NaCl over here. Because I am passing current, this Na and Cl will break. This Na and Cl will break. What will it form, sir? Na will form a positive ion and chlorine will form a negative ion. How, sir? Atomic number of sodium is 11. 2, 8, 1. It will easily lose one electron to form Na plus. What about chlorine? Atomic number is 17. 2, 8, 7. It will easily gain an electron to form chloride ion. It will easily gain an electron to form chloride ion. Cl minus ion is called as chloride ion. Okay, we have already seen that. What have we already seen? Negative ion is called as an anion. The positive ion is called as an cation. We have already seen that the negative ion is called as an anion. The positive ion is called as a cation. Okay, sir. What is the next thing that we are going to teach here? Here, this cation is positive and the cation will be attracted towards the negative electrode. Sir, how, sir? Cation is positive. Let me repeat, cation is positive. I have already told you how to remember this. Cats are a lot of fun to have at home. They are positive, cation positive. I had a teacher who used to always thrash me like anything. So dedicated to her, I have remembered anion to be a recollection of all my sweet memories of getting thrashed by my miss. Okay. Yeah, so that is basically anion. Dedicated to anion is negative anion. Dedicated to cats at home, positive cation. Because cations are positive, they will be attracted towards the negative electrode, and the negative electrode is called as cathode. The negative electrode, because this electrode attracts cation or positive ion, it is called as cathode. Similarly, let me look at anion. Anion is negative, so it will be attracted by the positive electrode. Anion is negative, so it will be attracted by the positive electrode. Yeah, okay, sir. So this particular anion will be attracted towards the positive electrode, which is anode. Listen to this carefully. Students often get confused here. Remember, only cation is positive, anion is negative. Now cation is positive, it is attracted towards the negative electrode, so negative electrode is cathode. Anion is negative, it will be attracted towards the positive electrode. The positive electrode is anode. Are you able to understand this particular idea? Okay, sir. Now, sodium will be attracted towards the negative electrode. Chlorine will be attracted towards the positive electrode. Okay, sir. Now, what is going to happen? Okay, here the chlorine, this particular Cl minus, chlorine, what will it do? This Cl minus or chlorine will go towards the anode. Two chlorine molecules will combine with each other. They will form Cl2 and this will be simply sent out. So, Cl2 is formed at the anode. Are you comfortable with this? Yes. What is the next thing, sir? Here you have brine. Brine is nothing but a mixture of salt and water. A thick mixture of salt and water. The water present will break to give H plus and OH minus ions. The water present will break to give H plus and OH minus ions. Here H plus is once more forming a cation, a positive ion. So this H plus immediately will move towards the cathode. This H plus will immediately move towards the cathode and it will combine to form H2 molecule. And this H2 molecule will be sent out from the cathode. This H2 molecule will be sent out from the cathode. So H2 is sent out from the cathode. Are you comfortable with this story? Okay. NaOH is formed near the cathode. NaOH or sodium hydroxide is formed near the cathode. Let us look at this reaction. NaCl plus water, which is in fact brine, I can simply call this as thick brine. You are putting electricity here. When you are putting electricity here, what is happening? You are getting NaOH plus H2Cl2. You are getting NaOH plus H2Cl2. Are you comfortable with this? In the Tamil lecture, I forgot to mention that you need to put electricity here. Yeah. So Tamil students listening, be careful. You always need to put whatever material is helping the reaction. Here electricity is actually helping this particular reaction. Electricity is breaking brine. Electricity is decomposing brine. Are you comfortable with this idea? Okay, sir. Now I need to balance this. How are you going to balance this? I have 2 chlorine over here. So I will put a 2 here. I get a 2 sodium. I am going to get a 2 here. Here I am going to have 2 oxygen. So I am going to put a 2 here. 4 hydrogen. Here also I have 4 hydrogen. Yes. This particular equation is beautifully balanced. Okay, sir. Now I have understood Chlor Alkali process. Now we are getting 3 products from Chlor Alkali process. We are getting an alkali, sodium hydroxide, we are getting hydrogen and we are also getting chlorine. What are the applications of the products of Chlor Alkali process? This is an often repeated CBSE board question. Okay, let us look at the applications from NCERT book perspective. Can we do this? Yeah, come on guys, let's do this. First, let us take hydrogen, the product hydrogen. Hydrogen is used as a fuel. Obviously, hydrogen burns with a popping sound. It is extremely combustible. Hydrogen is used for producing margarine. What is margarine? Margarine is synthetic butter, an artificial butter, not synthetic. Margarine can be called as artificial butter. Hydrogen is also used for producing ammonia, which is in fact used for manufacturing fertilizers. Hydrogen is used for producing ammonia. Ammonia is used for manufacturing fertilizers. Okay, sir. What is the process of manufacturing of ammonia called as? The manufacturing process of ammonia is called as Haber's process. It is a very important topic. Haber's process. It is a very important topic that will be learnt when, sir? When you are going to study in higher secondary chemistry. Okay, that's basically the applications of hydrogen. Let us look at the applications of chlorine. Chlorine is used in water treatment. Sir, Why is chlorine used in water treatment? Okay, chlorine is used in water treatment because chlorine has the tendency to steal electrons. Okay, sir. Why? Atomic number of chlorine is 17. The electronic configuration of chlorine is 2, 8, 7. Okay, sir. I know this. I do remember this. Okay, let me write it up. Chlorine 17, 2, 8, 7. So it will steal one electron from some place. Chlorine has the tendency to steal one electron in order to form argon, noble gas configuration. Argon, noble gas configuration. Yeah, yes sir. So chlorine basically has the tendency to steal electrons. Yes sir. So if you are putting chlorine somewhere, it will steal electrons. Yes sir. So all dust particles have electrons. Yes sir. So chlorine will steal electrons. Okay. And along with these electrons, the chlorine will clean the dust particles, because chlorine, what does it do? It steals electron from the dust particles, and along with the electrons, the dust particles are also cleaned by chlorine. The dust particles are also cleaned by chlorine. If there are pathogens and bacteria in water, if you are adding chlorine, what will happen? Chlorine will steal electrons from the bacteria. The bacteria will simply die. So chlorine is used for water treatment. It is used in swimming pools. In fact, in swimming pools, if you are adding too much chlorine, that excess chlorine will steal all the electrons from your body. It will steal some essential oils and fats in the skin, and this can result in rashes. When you are using swimming pool with too much chlorine, what happens? You get a lot of rashes. That is because chlorine, excess chlorine, steals the electrons even from your body. So chlorine can be used as a disinfectant. It can be used in the manufacture of PVC, polyvinyl chloride, CFC, chlorofluorocarbon, and pesticides. That's basically the applications of chlorine. What next, sir? NaOH or sodium hydroxide. Sodium hydroxide is a very strong base. Okay, sir. Oil and grease is a slightly acidic in nature. So, when you are adding a very strong base to the grease on the metal, it can be used to neutralize and clean the grease on the metal. It can be used to neutralize and clean the grease on the metal. Also, sodium hydroxide is used in the manufacture of soaps and detergents. You will study more about soaps and detergents when, sir? In the unit carbon and its compounds. In the unit carbon and its compounds. Also, sodium hydroxide is used in paper making, and it is used for artificial fibers. It is used in artificial fibers. Okay, so once more, hydrogen and chlorine, the two products of Chlor Alkali process, hydrogen and chlorine, they combine with each other in order to form hydrochloric acid, and that can be used for cleaning steel. It can be used for medicines and other cosmetics. It is used in the manufacture of ammonium chloride, which is an important chemical in the lab. Okay, sir. What about chlorine? Where am I going to use chlorine? Chlorine is used in the manufacture of bleach, and bleach is used for household bleaches and bleaching fabrics. In fact, let us look at an in-depth analysis of bleach. Can we have an in-depth analysis of bleach? Yes, sir. What is bleach called as? Bleach is called as calcium oxychloride. The chemical name of bleach is calcium oxychloride. Its formula is CaOCl2. What is the formula for bleach? The formula for bleach is CaOCl2. So, how is bleach manufactured? Bleach is manufactured by the action of chlorine gas on dry slaked lime. What is slaked lime? Calcium hydroxide is called as slaked lime. So if I am taking some slaked lime and putting dry chlorine to it, I will get bleach plus water. Okay, sir. So the formula for bleach is CaOCl2. Yes, the formula for bleach is CaOCl2. But, let me repeat it, but The actual formula is quite complex. For bleach, this formula is purely representative. For bleach, this formula is purely representative. The actual formula for bleach is quite complex. We are going to ignore it here and we will simply learn bleach to be CaOCl2. Okay, if bleach is left to stand for a long time, what happens, sir? Bleach decomposes and gives chlorine. Let me repeat. Bleach decomposes and gives chlorine. What is the nature of chlorine? Chlorine steals electrons. Chlorine steals electrons. So, if I am adding bleach to something, because it releases chlorine, it has a electron snatching nature. It has a cleaning nature because chlorine steals electrons from the dust particles. So, bleaching action is happening. Bleaching action means cleaning action. Cleaning action. You can even bleach your hair. What is bleaching the hair? Bleaching the hair means you will add what? A slight variation of bleaching powder to your hair, not to your head. It will steal the electrons and your hair for some time it will become white in color, and your hair for some time will become white in color. Do not try this at home. Kindly do not try this at home. Yeah. Cheers. Sir, what have you cut off here? Bleach, if it is allowed to stand, it undergoes auto-oxidation. What is auto-oxidation? Don't worry about this particular point. I will teach about auto-oxidation in the first unit. So, if you look at the lectures of the first unit, in redox reactions, in the topic redox reactions, we will talk about how bleach is undergoing auto-oxidation and bleaching action or cleaning action is happening. So essentially bleach is used to clean impurities. Bleach is used as a disinfectant. Yes, let us look at the applications of bleach. Bleach is used for bleaching cotton and linen in textile industry. What else, sir? It is used for bleaching wood pulp in paper industry, bleaching washed clothes in laundry. Okay, all these are bleaching applications. It is also used as a oxidation agent in a lot of chemical industries. Sir, how is bleach used as an oxidation agent? Once more, we will talk about this particular topic in the first unit, where we will study about the different types of reactions, specifically redox reactions. Finally, bleach is used for disinfecting drinking water because bleach is stealing electrons. It will steal electrons from all the bacteria and other pathogens in the water and simply kill them. So it makes water free from germs. Bleach makes water, because it releases chlorine, free from germs. Are you comfortable with this? That is the end of our lecture. Yeah, hope you guys enjoyed this lecture, because I had so much fun taking this particular class to you guys. Yeah, if you like our lecture, obviously subscribe to us, click the bell icon. What else? Recommend our channel to your friends and also promote our channel in social media. We will have so much fun learning chemistry together with 100% depth and clarity. Yeah, cheers and thank you. See you guys in the next lecture. Cheers and thank you.